Hi, I am Krishnaveni, Assistant Professor, PG and Research Department of Computer Science, Kamadhenu Arts and Science College, Satyamangalam. Today I am going to discuss about digital logic gates. First, what is meant by digital logic gates? A logic gate is an electronic circuit or device which makes logic decisions. The logic gate have one or more inputs and only one outputs. The basic gates are classified into three categories: AND gate, OR gate and NOT gate. First one is AND gate. The AND gate performs logical multiplication, is commonly known as AND functions. The AND gate has two or more inputs and a single outputs. The output of AND gate is high, only all the inputs are high. If X and Y are two inputs, the output F can be represented as Z equal to X dot Y because the AND gate performs logical multiplication. So the equation is Z equal to X dot Y. So this one is the logical representation of the AND gate. So in this diagrams we have the two input signal X and Y and only one output signal. The output signal is Z. So in this truth tables we have two input signals and only one output signals. The two input signals are high, the output will be high, otherwise the output is low. Next one is OR gate. The OR gate performs logical addition, is commonly known as OR functions. The OR gate has two or more inputs and a single output. The output of OR gate is high only when any one of the input is high. If A and B are two inputs, then the output can be represented as F equal to A plus B because the OR gate performs logical additions. So this is the logical representation of the OR gate. In this diagrams we have two input signal A and B and only one output signals. This one is the truth table for the OR gate. So in this truth table we have any one of the input signal is high, the output is high, otherwise the output is low. Next one is NOT gate. So the NOT gate performs basic logic function is called inversions or complementations. The NOT gate is also called an inverter. So the purpose of this gate is to convert one logic level to opposite logic level. It has one input and one output. If A is an input, then the output Q can be represented as Q equal to A dash because the NOT gate performs complement operations. So Q equal to A dash. So this one is the logical representation of the NOT gate, one input and only one output. So in this truth table, the input value is 0, the output is 1. So the input value is 1, the output is 0. Next one is NAND gate. The NAND gate is a cascade of AND gate and NOT gate. It has two or more inputs and only one output. The output of NAND gate is high when any one of its input is low. So logical representation of the NAND gate is, this one is the logical representation of the NAND gate. In this NAND gate we have the two input signals and only one output signals. Next one is the truth table for the NAND gate. So in this truth table, both the input values are high, the output value is low, otherwise the output value is high. If A and B are two inputs, then the output Q can be represented as Q equal to A into B the whole dash. So next one is NOR gate. The NOR gate is a cascade of OR gate and NOT gate. It has two or more inputs and only one outputs. The output of NOR gate is high when any one of the input is low. If A and B are two inputs, then the output Q can be represented as Q equal to A plus B the whole dash. Logical representation, this one is the logical representation for the NOR gate. So we have the two input values and produced only one output values. This one is the truth table for the NOR gate. So in this truth table, both the input values are low, the output value is high, otherwise the output value is low. Next, the last gate is XOR gate. That is, an XOR gate is called as an exclusive OR gate. So the exclusive OR gate is a gate with 2 or more inputs and 1 outputs. The output of a 2 input XOR gate assumes a high state if one and only one input assumes high state. This is equivalent to saying that the output is high if either input A or input B is high, low when both are 1 or 0 simultaneously. If X and Y are 2 inputs, the output Q can be represented as Q equal to A into B dash plus A dash into B. So this is the logical representation for the XOR gate. In this diagrams we have 2 input signals and only 1 output signal. So this is the truth table of XOR gate. So in this truth table, both the input values are low or both the input values are high, the output value is low. Suppose any one of the input value is high, the output value is high. Thank you.